Hello and welcome to another video on parametric railings. Recently, a customer sent us a link to a video and asked a simple question. Is something like this also possible in SolidSteel parametric? Our answer is yes. Anything that follows clear rules and can be described using equations can also be automated as a railing in SolidSteel parametric. The railing we're looking at here will look like this. A vertical bar railing mounted on a sheet metal stringer for concrete stairs. While the vertical bars are mainly a design element, a continuous handrail is not just a matter of appearance. In public and multifamily buildings, it is a requirement. That's why this railing includes a continuous round tube handrail, running at a consistent height and precisely following the stair geometry. We start with a simple concrete staircase. In order to mount the railing on a steel plate, we first extrude that plate as a new part based on the existing stair geometry. We select this side face. The default extrusion of 5 mm works fine, and we can confirm. Okay, the steel stringer now has the same color as the stairs, but that's not a problem, we know it's there. Now we switch to the SolidSteel parametric tab and select the custom railing feature. The template called bar railing 01 is already selected in the dialog because it was the last railing I added. As usual in SolidSteel, we now simply select the mounting face and then an edge to define the direction. By selecting this edge, the length and the inclination angle of the main railing are already defined, as you can see in the preview. At the top of the dialog, everything can stay as it is. At the bottom, in the equations section, this template offers a lot of variables that we can adjust. For example, handrail offset defines the horizontal distance of the handrail relative to the baseline. 150 mm is a bit too much here. 80 mm works better. Lower distance and upper distance define the lengths of the horizontal extensions at the top and bottom of the railing. Handrail mounting height is the counterpart to the first variable we changed. It defines the mounting height of the handrail bracket, measured downward this time, while the exact height of the handrail itself is defined separately in the top variable called handrail height. These settings are sufficient for our quick example, so we can confirm. Now the computer does the work for us. This takes a moment, as SolidSteel parametric creates an independent copy of the railing template and applies all adjustments to it. On my system, this took exactly 2 minutes in real time. I sped it up a bit for the video. So there's just enough time to grab a coffee, and then enjoy the finished result, which we'll now take a closer look at. Obviously we now have a railing made of flat steel, with vertical bars at equal spacing and an additional handrail. Here's a nice detail. This 90-degree bend at the end of the round tube, prepared for connecting the next handrail segment. Both the angle of the bend and the overhang could also have been defined parametrically in the dialog. From this side, you can see the handrail brackets. Their size was defined earlier using the 80 mm values. The number of vertical bars between the welded mounting points for the brackets is also individually adjustable in the dialog. There's really not much more to say, it simply works, it's fast, and it's flexible. Of course, SolidSteel parametric does more than just model railings. Subsequent processes, such as bills of materials, are fully supported as well. Let's have a look at it. First, we automatically assign position numbers. This also performs a geometric identical parts detection, so identical components receive the same position number. When we click on a position number, the corresponding parts are highlighted in color. Here we have the upper and lower vertical infill bars. Here are the short handrail segments at the top and bottom, and here the long segment. I don't immediately see position number 5. Let's check. Okay, these are the small vertical handrail brackets. These flat steel parts are diagonally symmetric, which is exactly what you would expect given the railing geometry. And this continues for all remaining position numbers across the entire railing. Position 12 refers to the bent segments, and position 13 already belongs to the staircase. Next, under Bill of Materials, we first select Update Metadata. This writes the properties into all parts. We confirm in the upper left of the dialog. This takes a few seconds. Once the icons turn colored again, the process is complete. Now we export a bill of materials using the corresponding feature. We select a template, choose a language for the header, and the assembly selected below is already correct. Then we define a file path and a file name and confirm. This only takes a few seconds. Let's take a look at the BOM, which has been saved as an Excel file. The bolt list for a welded construction is rather boring. The quantity list contains the complete assembly and clearly shows the identical parts grouped by position number, including their quantities. The sheet list contains only the stringer plate, with quantity, thickness, length, width, area, and weight. The beam list is sorted by different profile types, and the structure list is sorted by assemblies. The saw list is everyone's favorite in the workshop, showing profile type, length, and cutting angles. As you can see, working with railing templates in SolidSteel parametric is fast and flexible. Creating a railing template does of course require some initial effort, but this pays off very quickly. If you'd like to learn how to create your own railing templates, take a look at the upper recommended tutorial video. And if you want to see more railing variants, check out the lower recommended video. Thank you very much for watching, and see you next time.